All right, here we're looking at 1.2.2, reflect a function across the x or y axis, and then example A. So graph f of x equals 2x minus 6, which I've already plotted here. So this is 2x minus 6 in blue, and the function g, whose graph is the reflection, and this is important, the reflection of the graph of f across the x-axis. How are their equations related? All right, so my original equation, we had f of x is equal to 2x minus 6. And what I want to do is I want to reflect across the x-axis. So each of my points is going to be kind of mirrored on the opposite side of the x-axis. So if I start with 1, negative 4, this point down here, I'm going to reflect that. Now it's 4 places away from the x-axis, so I'm going to move it up 4 places. All right, so that's being reflected across the x-axis. This 2, negative 2, the same thing, it dropped down 2, so I'm going to move it up 2 and mirror it to the other side of the x-axis. This point here, that's going to stay the same, can't reflect right on the x-axis. 4 positive 2 is going to drop down. Instead of going up 2, we're now going to go down 2, and then 5, 4, instead of going up 4, it's going to drop down 4. All right, and then I have these 2 other points here, and now I can connect these dots. All right, and these are going to keep going because we didn't set any limits on our domain or range. So if I look at each one of these points, this point is 1, 4. This is 2, 2. This is 4, negative 2. And then here I have 5, negative 4. So we're trying to figure out what's happening when we reflect across the x-axis. So my original point, right, I had 1, negative 4. Well, that point became 1, 4. I had 2, negative 2, and that became 2, 2. The point 3, 0 stayed the same. All right, that was the one that was right on the x-axis. 4, 2 became 4, negative 2. And then finally, 5, 4 became 5, negative 4. All right, now we're trying to figure out what's going on, what's happening here. What I notice is that all of my y values, with the exception of the 3, 0, because that's right on the x-axis, are changing. All right, they're kind of the opposite sign of what they were. So negative 4 became positive 4, negative 2 became 2, 0 again stayed as 0, 2 became negative 2, and 4 became negative 4. So what's going on here is that my y values are taking the opposite sign. Right, so again, positives become negatives, negatives become positives. And that's because we're flipping over the x-axis. Now, the y values are the ones that are changing. This is important. You've probably heard mentioned somewhere before, and you can kind of keep this in your mind, that a lot of times the statement f of x, this is basically your y value. Right, so here, my y values are taking the opposite signs. So that means my f of x is taking the opposite sign. That means your entire function, right, is being changed to a negative number. So if I have 2x minus 6, what I'm doing is I'm taking that entire group and I'm going to make that negative. So if you have a function, we want g of x here. And what's going on with g of x? Well, we're taking all of f of x and we're making that negative. This is when you have a reflection over the x-axis. So this is a reflection over the x-axis. All right, it's an important distinction on where that negative is going to go, because we're going to see in the next video, when we have a reflection over the y-axis, where that negative is going to be. So if you have a reflection over the x-axis, your y values are changing. That means the result of the entire function, right, this function f of x is becoming the opposite, it's becoming negative. So for one more time, for a reflection over the x-axis, you want to take the entire function and make it negative. Right, that's going to give you the reflection that you're looking for. And once again, in the next video, you'll see what happens if we reflect over the y-axis, and then we'll compare the two so we can see the difference between them.